Next video, we're looking at the Atwood's machine. This is a pretty common one that we come across in specialist mathematics because, as you know, there are just some questions that we love for some reason. So, two particles of masses 3 kilograms and 2 kilograms are both hung vertically and are connected by a light inextensive string which passes over a smooth pulley. Initially, the 3 kilogram block is 1.5 metres above the ground. Calculate the time taken for the 3 kilogram block to hit the ground once the system is released from rest. Now, it says a smooth pulley. That means that there's no friction acting on this plane. So let's get started. Now, I'm going to start resolving my vectors. You can see in this one that acceleration is positive in this direction. So when I start to calculate my forces, force equals mass by acceleration. My mass is 2 kilograms. My acceleration is positive in that direction, which means now T is positive and we're going to minus 2g. So T is going to be equal to 2a plus 2g. Now we can start looking at this one over here. So force equals mass by acceleration. In this one, the acceleration is in the negative plane. So it's going to be 3 minus a. And our force is going to be T minus 3g. Okay, so that's going to give me, well, what I've currently got. So I want to get this thing in terms of A, which means that I want to get this into here so that I can start grouping my like terms. So I'm solving simultaneously. So 2a plus 2g minus 3g is equal to negative 3a. When I group these, I'm going to end up with negative 1g. So 2a minus 1g equals negative 3a. I'm going to take this across by dividing both terms. Wait, no, I'm not. Didn't realise this was a like term right here. That's cheeky. Take him over. So negative 1g is equal to, that's going to become minus 2a, minus 5a. So now I've got that a is equal to negative 1g over negative 5. Now, as an expression, that means that A is going to be equal to 1.96 metres per second squared. Okay, so we're not done yet. It's asking us to calculate the time taken for the 3 kilogram block to hit the ground once the system is released from rest. So if it's from rest, again, we're going to be using our constant acceleration formulas. So the formula we want to be using is S equals U T plus 1/2 of A T squared. Like I said before, we don't really use these in specialist maths. The textbook does to get you connecting things from physics, I think. But in future, we're going to be using integration to work this out for ourselves. So S is the distance from the ground. So in this case, it's going to be 1.5. Initially, it's at rest, which means that's 0. T is the thing we're trying to find. And the acceleration is 1.96 metres per second squared. So substituting all of this in, I end up with this, which means that cancels out to be 0, and this can come across by dividing. So let me just pop that in my calculator. 1/2 times 1.96 gives me 0.98. Therefore, this thing has an acceleration. Sorry, that should be a t. That should be a t, and that should be a t. So, therefore, the time taken for this is 0.98. Something's gone wrong. This should have a squared, this should have a squared, which means that should be square rooted, which means that should be square rooted. So now I'm just going to square root that answer. And that gives me still 0.98. So the time taken for this thing is 0.98 seconds.